Welcome to the RAOB program's tropical weather diagram. The following examples are only available with the optional analytic module. Also note that the demonstrated click and drag sounding modifications were done with the optional photograph and interactive module. We have opened the sample sounding with the standard SKUT diagram view, and in the upper right corner is a custom data display of common environmental parameters often relevant to tropical and subtropical climates. These parameters are observed with the basic RAOB program, but only in the numerical and text output listings. However, using the optional analytic module, these environmental parameters can be better visualized and graphically analyzed using the tropical weather diagram. To see this diagram, we'll use the Displays menu, then select the tropical weather option. Note that you can configure RAOB to automatically open with this diagram by using the Options menu, then select Program Options, and then choose the tropical weather view, and then close. And next time you open RAOB, the tropical weather diagram will be initially displayed. And now we see 5 colorful nomograms along the left side of the sounding. They provide convenient graphical indicators of common environmental threats to tropical climates. Before demonstrating each nomogram's capabilities, there is one general limitation to all 5 nomogram indicators, and that is they are totally dependent on the plotted sounding data, with no external input. Most of these environmental indicators were originally developed using additional non-sounding factors such as radar and satellite imagery. However, these RAOB nomograms are a very good first guess until other data becomes available. A great advantage of this special diagram is how all the nomograms instantly respond to data changes. For example, let's click and drag dew point data and introduce a large dry layer. And as expected, the tornado and flooding indicators decrease. And increasing the surface temperature increases the heat index. Now we'll use the Restore menu option to return the sounding to its original data. So, with this tropical weather diagram, you can see at a glance the overall status of common threat factors. And by adjusting a few data points, you can make a general forecast of future conditions. And with experience in local geography and weather conditions, you can make fairly good short-term predictions with RAOB's interactive capabilities. But the real power of this diagram is what lies behind each of the 5 nomograms. They are user configurable. They are installed with default predictor values, but they can be individually configured for your specific climate, location, and season. So let's see these configuration options. And as with all of RAOB's diagrams and nomograms, just right-click for more information. And we'll start by right-clicking on the TC Tornado nomogram, which is short for Tornado Potential for Landfalling Tropical Cyclones. And up pops its Configuration Options panel. And also notice that the panel has 5 tabs, one for each of the 5 nomograms. And if we close this Options panel and then right-click on the Waterspout nomogram, up pops the configuration panel already preset to the Waterspout tab. But for now, we'll select the TC Tornado tab and examine its options. The TC Tornado indicator is a composite of 2 separate indicators. As of this video creation, they are the only 2 sounding-based objective predictors of tornado potential associated with landfalling tropical cyclones. Both parameters can be separately weighted according to local conditions and user preferences, where the current component values are displayed for reference purposes. Notice that these individual component data values can also be seen on the plotted sounding diagram in the custom data display listing. Note that the first parameter is generated as a probability value, while the second parameter is a non-dimensional index, which RAOB transforms into a representative probability factor for nomogram display purposes. And now back to the configuration panel. Notice the generic description of each parameter and the optional info buttons at the end, where when clicked, they display related information from RAOB's built-in help files. Okay, now let's move on to the Waterspout tab, where we can see its component parameters and weighting options. Note that if you alter the weighting values, you can always return to the default settings with this button. Also note that the Waterspout 2 index is not included here as a component value, because the Waterspout 2 index only applies to the Great Lakes region and other cold water regions. And now on the flooding tab, as of video creation, there is only one known flooding parameter, which is completely based on sounding data alone. When other similar parameters become available, that will be added as an additional component option. Now let's look at the thunderstorm category nomogram. This is the same nomogram seen on the severe weather display screen. This nomogram shows that this sounding has some potential for strong thunderstorms. Specifically, the RPM value, which is listed just below the storm category title, and shows a value of 46%, is the same RPM value seen at the bottom of the soundings parameter listing. RPM stands for RAOB parameter metric and is used throughout the RAOB program as a consolidated index measuring the potential for strong storms. It's very important to note that the storm category nomogram consolidates over 50 key thermodynamic parameters and indices produced by the RAOB program. And while this storm category nomogram consolidates all these parameters into one graphic view, the RPM value defines this graphic as a single numeric indicator. In essence, this RPM value says that 46% of all severe weather indicators for this sounding fall into the strong category. And there's more to this nomogram. Just right-click on the nomogram and you'll see two severe weather parameter buttons. The severe weather parameter summary table button displays a tabular listing of each component's storm category, and the summary RPM value is shown at the bottom of the listing. The severe weather parameter configuration table button displays all the individual parameter threshold criteria, which are all user-defined and configurable. Parameter weighting is also user-defined. The last nomogram, the heat stress index, is the simplest of all nomograms since it has no configuration options. It only displays current values. However, predictors can be added as customer requirements are known. That completes the tropical weather diagram demonstration. Thank you for watching.